Greetings. Now let us move to the part 2 of technologies, policies, and practices for sustainable and clean energy system. This is Dr. Deepak Vaikar, now sharing with you part 2 of this sustainable energy systems. We have gone through introduction, current scenarios, and we started looking into technologies, policies, and practices. We'll go more details into this topic, then also identify challenges and opportunities and future possibilities. So that is what we are looking for. Now, according to World Energy Council, we should work on achieving energy efficiency in entire energy supply chain, generation, transmission, distribution, and utilization. So whatever is our current load, if we can do energy efficiency in entire supply chain, then there is a good possibility that we may be achieving the goals set at various accord. So first thing, it has been recommended that we should be ready to change our behavior. What does that mean? Just switch off lights, fans, and devices when not in use or not required. Okay. And according to World Energy Council, there is a scope up to 15% of saving. What does that mean is if you utilize 100% of the energy conservation, then if our current load is 100 units, it can be reduced to 85 units, saving of 15 units by just following energy conservation practices. Example, okay. Here I'm showing that a big Bitcoin which consumes a similar amount of power to that of Netherlands. Now, if that is such a high energy annual consumption of just trying to conduct the Bitcoin transaction, then we need to relook into this kind of applications. Okay. This is one part. So this is change in behavior. Mining or bitcoins using fossilized fuel is going to ruin us. One, two. Yes, even annualized electricity consumption is expected to exceed 500 terawatt hours. If that is the kind of electricity is being consumed, then this is one of the behavior we have to change. While on the other hand, during pandemic, all of us were in online, then it did help. It did help to increase our energy consumption. However, it was necessary. Probably it would have been compensated by equivalent reduction in consumption because of transportation system. And if that study can be correlated, then this kind of using online to cut down our emissions and reduction in energy consumption will be useful. Now, look at it now. We just looked at it. Doctors and scientists are saying whose lungs are weak and whose blood sugar level is very high. Now, this is this condition, again, behavioral condition. Then what we should do? Okay, we have choices. All of us know that sugarcane is converted into sugar, and one of the reasons of because of our lifestyle and heavy consumption of sugar coated uh, food, that diabetic tsunami has occurred. It is coming everywhere now almost. And if we wish to continue that behavior, then it is going to affect our healthcare system. People will be requiring more healthcare, and that is not good in long term. On the other hand, if we can use probably major part of the sugar cane to convert into biogas, especially ethanol, because ethanol is a industry which is a process based one. Okay, uh, it requires fermentation, conversion into ethanol, then blending with the fuel, and that can then be further blended with the hybrid vehicle. Okay, so this way it is possible to reduce our dependent on pure fossilized energy. Obviously, this is sustainable, and if you follow this kind of change in behavior, then we can achieve some of the goals. So, from 100 to 85 units just by changing behavior. Next, what they propose is further reduction is still possible if we use energy efficiency. Okay, energy efficiency, they say there is a scope to improve efficiency in various processes. Then, if that is realized, then our energy consumption from current 85 after conservation can go down as low as 60 units. Means so total energy conservation and energy efficiency can reduce 20, 40 units. So now our consumption is 60 units. It means we'll be requiring less energy to be delivered from fossilized devices. Example now fossil energy we use in our say campuses. We have got auditoriums, we need air conditioners, we need fans, we need motor generation set. Even our laboratories need uh, heavy devices. We need to we need transportation. So if we are using current conventional transportation, which uses diesel and petrol, then that is going to add to our energy consumption. LPG for cooking, then storage, and obviously cars and motorbikes. So these are the energy consumptions which are needed. But now how we can shift from that? That is, they call it energy efficiency. And according to Morton Wefferard, president of ABB Motion, energy efficiency is the world's invisible climate solution because we use large numbers of electric motors. This electric motor consume about 45% of electricity globally. So it means if you start using energy efficient electric motors, there is a tremendous scope to reduce our consumption of electricity. This is the one part. Second, it has been shown when you start using energy efficient electric motors and pumps and lighting, that takes us to demand side management. And once we reduce the consumption, then even our factories can become energy efficient. Robots are used everywhere, which uses electric motors. Then there is a tremendous scope to reduce energy consumption by employing energy efficient devices and motors and lighting and fans. That is another part. Another very important development. We are using digitization, which affects energy consumption. Yes, on the one hand, we can use digital devices to improve our energy efficiency. We can manage it better. But at the same time, because we are using more digital devices, then we need more data centers, more devices that can increase energy consumption. So it's both way. So we have to balance that out appropriately. Obviously, digitization has advantages, and if we want to move in digitization, it should be used appropriately, not for Bitcoin. So, by practicing energy conservation and energy efficiency, we can reduce our demand from 100 to straight away to 60 units. Now we are only paying for 60 units. We have already saved for 40 units. That is a saving has happened. Now, what we can do with this saving? That is the question. We have got saving of 40 units. We have saved the money. But what are the challenges then? Though we have saved money, what we should do about it? Obviously, yes, I mentioned to you, one is just now we have seen the blood sugar level is high. We can take action, behavioral change. Now, those whose heart doesn't want to work. There is another major problem we have got. What can we do about it? Okay. Oh, okay. What can we do to improve situation? Okay, that is the question. Obviously, the same world is what is it that is abundant in the world? Waste energy. Waste energy is abundant. Now, that is where if you allow it to go waste, then it is a loss. Then what we can do? Now we have a choice. On the one hand, we have got on the one hand we have got huge quantity of waste, whether it's the food waste, whether it's the garbage, even burning up the waste in farms. So whether burn and dump waste, that is one option, which is they call it destructive one. On the other hand, we can use this waste using technology to convert into energy. Okay. As you can see, there is a systematic process is there which can generate electricity, and not only that, whatever the byproducts are, they can be used for biofertilizers. So, and even it can be converted into bioethanol, biodiesel, bio-oil. So choice is entirely ours, whether we burn or dump the waste destructive way, or convert into energy. Put in chat box, because whether sustainable or destructive, which is the behavior we wanted. Okay, and if we choose sustainable option, it can be towards green economic future. So you can see now behavioral change. So now it means now we have started using renewable. Whatever we have said, 40 units. So maybe we have that money, we can now invest into renewable sources, which could be whatever renewable sources, which is shown in green here. So our now demand, which was 60, 30 is taken care by renewable. Now left with another 30, which is fulfilled by the uh, fossilized fuel. Now, what is the impact now? Energy conservation, energy efficiency, and renewable energy in simple form can reduce our energy consumption from 100 units to all the way to the 30 units. Okay, renewable energy can be useful in that way. Obviously, so whatever saving happening, invest in the renewable. And that is what energy management system advocates. Okay, that is what energy management system advocates. Obviously, for that to happen, we have to use smart strategies, whatever mentioned in management literature, specific, measurable, achievable, result oriented, and time bound. Okay, this has been used. That that strategy can be used now for energy management. And they say all this is another very standard one. There is a energy pyramid. There are various suggestions. They say we should use first energy conservation, followed by energy efficiency, and then once you save it, then you can use for renewable energies. Some of them might say, okay, now renewable energies are becoming affordable, so you can also start incorporating them as and when it is possible. Okay, so what is your feeling about renewable energy? Put in chat box whatever you feel about it. What is renewable energy? Okay, one of them is obviously solar energy. And there are solar energy if it's coming from the sun rays, and we use photovoltaic one, which depends on visible light. So one of the ways is we use standalone system, in which we need inverter, charger, controller, and a storage system, which can increase the cost. On the other hand, We can also use grid connected one in which storage cost can be reduced and we have support from the grid. So this can stabilize microgrid and main grid. So advantage is there. Obviously, solar power, this diagram shows uh, timeline. Okay, though it has been existing for right from the okay several billion years. Uh, how to convert that into electricity started somewhere in 1839, 1883. They say first solar cell was developed, and if you go through this process, solar power used in space technology, and then from space technology, it started coming to the civilian use. Say they okay from civilian use in 1982, then 1985, and around 1920s, 2016, they say one of the largest power plant using solar power was developed in China. And there are plans by 2050, 3,000 gigawatt of solar power is to be installed, and that could amount to 11% of total energy consumption by we, the people. So solar energy has future photovoltaic, but there are challenges. One is very low reliability because it is only available for certain period in certain countries, so it is not 100% everywhere. Then second part is solar cells. Okay, solar cells efficiency is becoming better, cost is going down, but the panel cost is still high and it requires maintenance. So efficiency is still low. We have to invest in battery storage or other type of storage in case we want to use a standalone system. So while things are moving in positive direction, but there are many challenges in this one, and therefore there is a high scope for research and development in solar PV. Okay, there are second another type they call solar thermal system, which can use various types of parabolic technology wherein sun rays fall on parabolic okay glasses, then it is reflected, then the heat is used for converting water into steam, and then steam generator it becomes electricity. Now obviously one other challenges it is yes, efficiency of solar thermal is comparatively higher than the solar PV as we mentioned last time. It is comparatively reliable and but requires higher space. So these are the challenges. Challenges means we have to then do more of R&D, okay, research scope for research and development, and there is need for appropriate collaboration to bring down the cost as well as to reduce the size of the solar thermal devices. Yes, that also gives us opportunity for what they call solaropreneurship. Okay, it has been happening. Many of them are setting up, such as one what we see is solar hut, then solar lighting. Also, we can see that water pumps, solar water pumps are available. Training is happening, and portable solar. Even telecom devices now can be provided with the solar energy, and these are the where even opportunities are there. Solarpreneurship, that is sustainable one. Now, very quickly, when you look at another device, they call wind energy. Okay, that is another renewable source of energy, but however, predominantly we require high wind speed, anywhere from 6 meters per second and higher. Reliability is low. Okay, kinetic energy from the turbine is converted using gearbox into electrical energy. Okay, the formula given is here, P equal to half of Cp rho A U cube. So, but at present, maintenance is still required for wind farms. Reliability is low. It depends on availability of wind. It requires higher space. Efficiency is comparatively low. Now, what does it mean? Now, yes, there is a research going on to bring in low speed micro wind turbines. Okay, that if that is can be thought about. Then there is a scope to reach. Yeah, R&D scope for micro wind, which can with micro wind turbine, which can generate electricity at lower speed, and that could be one of the very good area to research on and get the things out. Next renewable type of energy is using water. Okay, we know we has been used many times. Obviously, we know big hydro, but there are some challenges in that. There is scope for what they call is micro pico hydro. Okay, micro pico hydros using waterfalls. What you see here, or whatever the energy of the water can be transformed into electricity. Obviously, the formula is there that can be used to get electricity from micro hydro. And from ocean also. Ocean, there are two technologies. One is the tidal waves, which are coming, which can be used to drive water pump turbines, and then from there generators will provide electricity. So when there is a high tide, water comes in, water goes back again. Both way it can generate electricity. On the other hand, research is also going on ocean thermal energy conversion. Okay, we know that there is a temperature difference from the surface of the water and the deep in the if you go down the ocean. Okay, so what they say is that because of this temperature difference, some warm stream water can be brought up, which can drive the seawater pump. Then it can be used in evaporator, which is as a working fluid. Then the working fluid will get evaporated, goes into turbine. It will run turbine, and generator will produce electricity. Outside it becomes condenser. Then you again send it back to the cold water. So this is cycle. This is still in a research stage because it requires tremendous amount of investment. But this is what science and mathematics of clean and green energy is happening now. Another type of renewable energy is called geothermal energy. All of us know Earth, deep under Earth's crust, there is a high temperature. Obviously, deeper we go, higher, higher is the temperature. And but in some places uh, where there are volcanoes and such things, the uh, we can see there are hot water springs are there. Then what we have to do is we use again a technology. A water, cold water is injected into the well, goes deep, maybe up to kilometer or so. Then because of the it comes in contact with the hot surface there, it gets converted into a steam. It is brought up, steam is brought up, put into steam turbine, and electricity is generated, and the cycle continues. And obviously, this is where the geothermal energy can be there, and the research is also going on for converting uh, cold water into hot water or warmer water for other purposes. So not only for electricity but other purposes, and then you might be okay with the lesser temperature difference. Lesser temperature difference. So that is how geothermal energy is there. And just now we discussed about it. Okay, from sugarcane we can convert into uh, ethanol, and it can be used in the hybrid vehicle. So this is how we are moving using renewable energy into sustainable system. Another one which is well known is they call it biomass, which is the waste coming from animals and forest and farming, which can be then used to convert into what they call is thermal power stations, connect into electricity or heat. So the biomass is also widely used. Now, if we can use the renewables that are not producing high emissions, then it is going to satisfy the requirement. But in the event we have to still use fossilized fuels, then there is another technology which can be used. They call it carbon capture and storage. This technology can uh, capture CO2 coming from the power stations, and then they can be stored. So as a result, emissions will be reduced. But this one is expensive technology, still in the research phase, some demonstration plants were come, but now it has been promoted as one of the key technologies to address the climate change effect. Now, we have heard about the nuclear energy earlier. Nuclear energy, uh, they felt that because of the process, there are no greenhouse gases coming out of it. But however, a major problem is radiation impact and how we manage the waste. And we know typical Fukushima situation because of which the nuclear energy developments were affected. But as a result, now the uh, new nuclear technology is coming up, which has got better safety requirement, fast breeder reactors, or even new generations of reactors which are coming in. So nuclear power plants, because there is a separation of thermal fluid and the inside fluid, and that as a result, as long as proper safety mechanism is there, then it can provide a reliable source of energy, electricity. And interesting part is, according to researchers, nuclear power station, there is almost negligible greenhouse gas or CO2 emissions. And efficiency is still 36%, so better than the solar and wind. Now, obviously, we have to look at the what is possible. Okay, obviously, if we can manage safety and the radiation as well as waste management, then nuclear power plant could provide alternative for us to combat climate change. So, what do you think now? Is there a scope for hope or a pipe dream? I discussed with you various alternatives about renewable energy which can be used. Obviously, they will require investment. Okay, they are talking about more than $1 trillion industry. Now, another development has come, what they call drivers. Okay, drivers, we call it electric vehicles. Now, everyone is interested to know about it because electric vehicle, they say, would reduce pollution substantially in the places of diesel powered or petrol powered vehicles. Obviously, we need a large quantity of batteries and then a charging system. These are the two things. Batteries and charging system are the one which are keeping them at such a stage that their use is limited. As yes, many of them are saying we should provide subsidies so that people will start buying electric vehicle. But there are some who feel that subsidies are usually counterproductive, delay commercialization, and nearly lead to focus on milking subsidies rather than commercializing technology. Okay, these are different views. So we have to find a balance. Okay, so if because every few years you have to change battery, that part also must be considered. So what are challenges? Yes, we just mentioned. If we are going to charge our electric vehicle using fossilized energy, then it is not sustainable because then we will be emitting more CO2 gases, more pollution. On the other hand, if we use renewable energy as shown here, like a sustainable energy, as shown here, solar energy to charge our electric vehicle, then we can say there is a good scope for sustainability. So this way we can use combination of electric vehicle and charging system to reduce pollution and make it sustainable. This is one of the options, and obviously, yep, uh, in uh, March 8, 2021, Singapore has announced that there are no more new diesel cars taxis in Singapore from 2025. No more new. Okay, so it means they need to be converted into equivalent, which are either less polluting or maybe net zero pollution. Okay, and that decision has been made. It means there will be some requirement for that. Yes, it means That is where Singapore is going for in a big way for electric public transportation. Okay, uh, and they are promoting also charging station at various places, and therefore combination of uh, electric public transportation and electric vehicles can provide some opportunities to move into future. Okay, to move into future. So that can take care of, obviously one of the things is clean air. Yes, even you can think about it. Is this is happening? Okay, this is happening in one of the places in the United States of America. The solar charging for electric buses, and if this can be done, say like this, what we see is 1.5 megawatt fleet charger, which can charge up to 34 electric buses. And if that is the case, then obviously what will happen is pollution in cities will be reduced substantially. And then we are using, as we mentioned, solar energy to charge electric buses. Both of them combined can give good combination. However, cost is likely to be higher, but that can be considered to be useful considering the less pollution. Yes, some the new development, yes, some of them are discussing about now they are called solar trees to absorb greenhouse gases and pollution. Okay, these are uh, such that they can generate electricity, but at the same time absorb. So technology is still there. They are working on it. Is a new one. There is tremendous scope for research and development in such technologies. And yes, we have seen there are some solarized cricket and football stadiums, and more should be like that. Even solarized offices are coming now. Uh, a floating solar system is also being incorporated. Solarized buildings are there. So all these developments are happening, and as a result, there is now tremendous movement towards use of renewable energy, solarized energy, other types of energy. And as just mentioned to you, yes, solarpreneurship is there, solar hut, solar lamp, solar training, solar pump, portable solar system, solar powered telecom towers. So all this we combine, then as a result, what happens is we are moving towards substantial use of renewable energy. It means earlier we used 30 units of renewable energy, considering there was a limited scope. Now we can go down further from 30 units. Now fossil fuels is only 15 units. So out of 60 unit, after taking care of conservation and energy efficiency, now 60 units are there, and those 60 units are initially 50%, 50% coming, 30 units coming from renewable, 30 from the fossilized. Now with those development I discussed with you, we can go down further from 30 to 15 units. It means we are now drawing very less from the fossilized one, and this is how we are now using more renewable energy, and that is how we can move into sustainable direction. So yes, earlier we were talking about use of coal-fired power station, gas-fired, oil-fired, a lot of pollution, emissions, and we now converting into use of various types of renewable energy. So as a result, make a choice, sustainable S or destructive D. Which one you want to go? And if you go for sustainable options, then and using smartly, as we mentioned, smart way, and apply Industry 4.0 technologies such as artificial intelligence, analytics, big data, intelligence sensors. Then we have got what they call it smart grid and smart meters and smart apps so that we can manage our electricity more efficiently. And when we manage our electricity efficiently, energy management system, then our requirement is reduced substantially. Once your requirement is reduced substantially, we can do it better way. So this is what the future is. And obviously from smart grid is for bigger one. They are not talking about even building microgrid. And IEEE has proposed hybrid AC, DC microgrids, means combination of them. What they are saying is we need to have two separate buses. One is called alternating current and DC current, direct current. The DC devices can be powered using DC grid, and AC devices can be powered in the AC trees, and this is a multidisciplinary approach. And then we are connected with the uh, grid. Then it can work both in collaboration with the main grid, or it can have isolation system and work independently. So this is the fantastic development which can be used everywhere. We can even apply same big data, IIoTs, machine learning, artificial intelligence, ANN, okay, artificial neural networks, deep learning, and 5G are coming. Clouds are required, cybersecurity. So all those can be now incorporated into microgrids and smart grids. And when we do that, then our energy management becomes even more powerful. So now, as a result, what we can do now, I have shared with you a systematic process for transiting from fossil energy dominated scenario to the sustainable clean energy scenario. So we started with 100, then cut down to 85. From 85 we cut down to 60. From 60 fossil was only 30. From 30 then we got down to 15, and 15 now we even go down to as low as 5. Okay, so you can see now the tower for green energy is now higher and higher. As a result, now we have this is the systematic transition process: smart, clean and green energy future. And ideally, obviously, ideally, we want obviously ISO 50,000 has a tremendous role to play, and we have mentioned about the other various series need to be used systematically. All they must be applied, and industry should take lead in doing this one. We need more trained people in that one. So there is a tremendous scope for people getting skill and getting jobs also, okay, in this area, and it is going to help us to reduce the energy consumption tremendously. If that happens, obviously for doing the skills development, we as Radio Energy are doing our small whatever contribution in collaboration with World Energy Council. We have done it, International Energy Foundation. In previously we have done it. Now we are doing with IEEE and IUCC Foundation. So, and we have conducted hundreds of such keynote plenaries, panel sessions, and we'll be happy to continue delivering such webinars. So this is the vision we are proposing: smart, clean, and green energy future systematically. Okay, we invite you to be part of this. So is there a scope for hope or a pipe dream? Put in chat box. Put in chat box. So not not only that, now there is a scope to go do 100% clean energy. Not only that, what we are saying is your campuses can even produce more than 100%. It means you can export and start earning something. That is a clean, green economy. For that purpose, we have to do smartly, smart way. So, what is smart way we are recommending? Sustainable, market-driven, accountable, resourceful, and transformative. This is how we transform from energy which is dominated by fossil fuels to the clean energy, and not only that, from clean energy to green economy. If that happens, there is a tremendous scope for each one of us, and we will be living in a better world. That is what it is. So the question arises: what is your action plan? Okay, we have shared with you part one and part two what can be done. So what is your action plan? Yes, one of them could be now how campus can become surplus using renewable energy, clean energy. Okay, and therefore we mention to you now you take up as a project, write, prepare research proposal or a technical case study or article. Each one of you should do one of the things as per your interest. You can form team and also prepare it. Okay, that is also welcome. Prepare a technical study and choose one of them and go in deeper into it and learn from that, and then also write about it. That is what your assignment is. So your actions. This way you will become passionate about it. That is definitely needed. And all of us know ultimately energy, all it's most of them is coming from solar energy. There are different types of impact. Even solar energy is the source of almost all types of energies. So we can move in that vision. So in summary and conclusions, let me state that energy conservation, energy efficiency, energy management can help catalyze to accelerate energy transition from dominant fossilized energy to sustainable, clean, and green energy. For what? To fulfill net zero emission goals and objectives. Okay, many of them are setting goals for 2050, 2060, 2070. So hopefully that with combined effort and strong research and development support from government and industry taking the lead and academician contributing to the research, it is possible that we might achieve that as per the stated goals or maybe even early, depending on the breakthrough coming. Yeah, they are talking about also green hydrogen. So that part I have not covered. So let me share with you one of my compositions around August 2020. It got revealed to me net zero pollution, net zero waste, net zero energy at its base. Make them part of everyday routine. Keep our surroundings clean and green. And in this case, we start with the clean and green energy, and that can help us to reduce pollution. And maybe we are going for net zero. That is what I would like to acknowledge the support given by all these organizations for helping me to prepare this presentation, including our invitees. Thank you very much. This is Dr. Deepak Vaikar sharing with you technologies, policies, and practices for sustainable, clean, and clean energy systems. You are most welcome to ask questions and send us your comments, views, and we'll be happy to work with anyone to take this as a research project. Thank you very much. Have a wonderful day.